Your second standard in the muscular unit is about how muscles act as levers. They work in conjunction with the bones in your body, with the joints, specifically synovial joints, to create more efficient systems for doing work, primarily in the way that levers do. Your standard reads, I can explain how the attachments, locations, and interactions of skeletal muscles make certain movements possible. And this covers section 9.6 of your textbook. So, a review from last time, the muscular system has three distinct types of muscle. Skeletal muscles were the ones you controlled and the ones that moved your bones. So, again, those are the ones we are going to be discussing today. But be aware that cardiac muscles that allow your heart to beat and smooth muscles that move things through your intestines, both involuntarily, also exist. Okay, your new heading for today, MUSCLE.2 Skeletal Muscle Actions. Skeletal muscle is responsible for a lot of different types of movements. You have these very small, articulate movements that you make with your hands. You have much larger, brute uses of force that you use when you're lifting things or pushing things, but there's a really big variety. The action that a muscle is capable of performing really depends on the joint that the bones around it are attached to, as well as the attachment sites of those specific muscles. So we're going to compare muscles to levers. In middle school, you discussed simple machines and the ways that they make work easier. You discussed pulleys, you discussed wheels, but we're going to use levers as our example for muscles. So when we're discussing a lever, we have three different classes, but we're just going to look at the first one for now. There's four parts to a lever. We have a rigid bar of some sort, a fulcrum around which that bar moves, we have a resistance or a weight, and then we have a force or an effort. So anatomically, the rigid bars of the levers are your bones. So if we're talking about what you're doing with your biceps, those are going to be your humerus, your radius, your ulna. The fulcrum are the joints, so this could be your elbow or your knee or your wrist or one of your finger joints. Whatever object you're moving, even if it's as small as a pair of tweezers or a pair of scissors, that is going to be the weight, and then your muscles will provide the force to move that weight. The way that we classify levers is based on the order of resistance, fulcrum, and force. And the easiest way for me to memorize it is by memorizing what is in the center, because what's on the left can be the same in multiple examples. For instance, in first and third, resistance are the first ones that appear, but the center is always unique. So in a first class lever, your fulcrum is in the center. And this to me looks very much like a seesaw. We have the weight on one side and the force on another. The example that they use is a pair of scissors. You provide the force on one end, the fulcrum is that center point, and then the weight or the work that you're doing is on the other side. A second class lever has the weight in the middle with the fulcrum and force on either side. This is much like a wheelbarrow. The entire system moves around this wheel, but the weight is in the middle and the force is on the other side. A third class lever has the force in the center, so this would be your pair of tweezers. They're connected at one end, you're providing the force in the center, and you're doing the work at the other end. For this standard, you're going to have to classify specific muscle movements based on what class of lever they are and identify specific terms related to how muscles do work. So we're going to do an example here together using the idea that this person is lifting a weight using their bicep. So first term, the agonist is the muscle that's causing the action. It's the muscle that's doing the work, the one that's contracting, the one that's shortening. And so for this example, it would be our biceps. We can see very clearly that he or she is using their biceps brachii to lift up that weight. Sometimes a synonym for the agonist is the prime mover. In most of the examples I'll show you, it's the primary muscle causing the movement, just it's the same as the agonist. The agonist itself has two attachment sites. Usually one of them is more mobile than the other. So for instance, if this were like a GIF and you could see it moving, um, the forearm would be moving up and down, the shoulder would not be moving very much at all. And if we're looking at these two attachment sites, that means that this end right here would be moving a lot more than this end, which would be pretty stationary. So the less movable end of the agonist is referred to as the origin. So here is its origin, where it attaches to the scapula. The mobile end would be the insertion. So this would be where it attaches to the radius. You always have to mention the muscle name as well as the bone name when discussing these attachment sites. The antagonist is the opposite muscle. So almost every muscle we have exists in a paired grouping. Even things we might not consider, like our pectorals, are balanced by our lats in the back. So the antagonist is whoever is relaxed. In this case, our biceps brachii are our agonist, so our triceps brachii would be our antagonist. Lastly, the synergist is any muscle that assists the agonist. Any muscle that's in close proximity can be assumed to be helping out. So for instance, maybe the deltoid here on the shoulder or the pectoralis major, any of those that are helping out the agonist just based on proximity.